All right, as we get started today, practice exercise 63, practicing with some roots there. Most of them you memorized in elementary school, but some of them, it'd be really helpful if you remembered them from last year, or in Jamie's case, a few years ago. But exercise 63, no calculator. Go ahead and begin. First person done if you'll stand, and then keep track after that. All right, let's go and take a look at these together. And Ethan, you were first. Ethan, what did you get for that first row going across?
4,
good.
8,
yep.
12,
yep.
3,
yep.
2,
yep.
5.
Good. 4, 8, 12, 3, 2, 5. Should have been perfect on those. Next row going across.
11,
yep.
9,
yep.
1,
yep.
10,
yep.
7,
yep.
13.
And the only one on there that we would have had to remember from past years was 13 there at the end. So 11, 9, 1, 10, 7, 13. The fun part came in how many perfect on the top two rows? Everyone should have been perfect on the top.
I skipped one and I forgot to go back to it.
Okay, all right. Bottom row, this is where we had to evaluate. And again, it says square root of 4, square root of 25, and square root of 9. Please tell me you didn't actually plug those in. Please tell me you actually plugged in 2, 5, and 3, right? Hopefully, okay. All right, so ABX becomes 30. 3AB becomes 30. 3a plus 2b minus 4x becomes 4. And x plus 7ab becomes 73. Got them all. Excellent. Anyone else get them all correct, though not as fast as Ethan? All right. How many of you just missed one? Just missed one. Okay, just missed 2. Questions on any of these? All right. I'm going to go and collect those from you. And if you would go and take your homework out, you practiced constructions 9 through 11. You practiced constructions 9 through 11 for homework over the weekend. Now for construction 11, that was one where you were dividing a line into any number of parts. I told you I wanted you to have 4 equal parts, but I didn't want you to use the bisector method. I wanted you to do it the method that I taught in class. So go and have that homework out. And if you would go and hold it up so that I can see, maybe it's 2 pages, maybe it's a front, back. I'm going to go around one at a time and acknowledge that I see all 3. So I see 2, 3. Excellent. There's 2, and then that third one, yeah, that parallel didn't come out too good. And actually see why. When you make that arc, it's got to go through that long line coming down here. The arc's got to start there and go out. So you have to have something to measure, and that's what we didn't have. All right, there's 1, 2, and on the back side 3. Excellent. 1, 2, and 3. 1, 2, 3. 1, 2, looks like 3 there. Something still not right. I'm not sure what. All right, and then 1, 2, and 3. Excellent. Okay, let's go and take a look at these together. By way of review, Construction number 9 was simply to bisect an arc. So you should have taken your compass and on your paper made some arc. How many went minor arc? How many made a minor arc? How many went and made a major arc? Anyone try to make a semicircle?
Actually, I'm a semicircle.
All right. So that's approximately a semicircle. It looks like it's actually slightly major arc. Doesn't really matter. Regardless of how you drew your arc, the first thing, Quentin, we should have done was to draw a line. What line?
From end to end.
From end to end. So really what we're drawing is technically called a chord. And in fact, since we are making a chord and an arc, this area in here, class, is called a
segment.
Segment, right? The region bounded by a chord and its arc is called a segment of the circle. So we got this segment of a circle now. Then what, Audrey? Could we construct the perpendicular bisector? We do what construction 1 tells us to do. Put the point of the compass on an end point of the arc, or of the chord, well, either one. Open your compass more than half, make an arc above and below. Now, this isn't necessarily an arc of significance. The whole arc has significance. Go to the other end point, keeping the compass open the same amount, make an arc, make another arc. Ooh, just barely fit there. And then remember, we're going to want to connect those dots. Now, I emphasize to you, especially if you've got a major arc, it will occasionally happen if all you do is connect the dots, you will not have actually bisected the chord yet, right? So I want to make sure that we take that line all the way up so that it does bisect the arc itself, and there's our 2 equal sections of the arc. It also allows us to see that, yes, it appears I have 2 equal segments here. I appear to have a perpendicular. It appears I've done the construction correctly. And how many have this on your paper? I think this is perhaps one of the easier constructions we've done. I mean, it's basically construction 1 with a line first, right? So really not too bad at all. Construction number 10, you were supposed to draw some line on your paper, and you were supposed to construct a parallel to this line through some point. So you're supposed to draw some point up above the line. You're supposed to put a parallel through that point. Chris, what would we do first here?
Open your compass past the line from the point, like put the point of your compass on the point that was given, and open it past the line.
All right, we could do it this way. What Chris is suggesting is do the Cyclops or the Mike Wazowski construction, the smiley face construction, whatever you want to call it, construction 5, and make a perpendicular straight down, extend it up a little bit, and then do construction 4. Little tick marks here, tick marks out here, and then that'll double perpendicular.
That's the way I found easiest.
And that's fine. I want to review the other way, though, that I taught you. Construction 5 followed by construction 4 works great. Jamie, what's another way in which we could do this? The little bit faster way.
Draw a transversal.
Okay, let's start with a transversal through the point, and I don't have a lot of room to go like this. I guess I could, or I could go like this. Do you want to slant to down and left or down and right?
Down and right.
You want to down right, okay? Well, that's down right.
Could you just go and make a straight line?
You could, but you're going to have a harder time. What you really want to do, Chris, with this one is to create an acute angle. You want an acute angle on one side or the other. Now, technically, I guess you could go obtuse, but I like acute angles better. And then what, Jamie?
And then you copy the angle.
Good, then we want to copy this acute angle. So open the compass up so it doesn't go past that point, but you also want to be able to fit it here. Okay, that doesn't fit. So maybe this would fit here. And so we're going to put the point of the compass here and make an arc. And then we also go to the point and we also make an arc. Then we're going to
put the end of the compass at one of the endpoints of the arc.
Okay.
And measure.
Yeah, we're just going to measure the arc. So we make an arc down here at the intersection point, but we also then make an arc from the point. Then we measure this arc, and we also measure
the arc up
here. And once we've measured that off, we simply, class, connect the dots. So I mean, it's literally one line, 2 arcs, 2 measurements, and connect the dots, and you're done much quicker than the double perpendicular. That said, the double perpendicular works. And if it's more accurate for you, don't knock it, but I'm lazy. I'd rather do the fewest steps possible. So this is my method of choice. How many did Chris's method? Construction 5 followed by 4? Right? Nothing wrong with it. Nothing wrong with it. I taught it for a reason, right? I mean, if I didn't like the method, I wouldn't have even mentioned it, okay? So I have no problem with that method whatsoever. How many then did it this way? I did it work out for it. Do your 2 lines look parallel? Anyone say, my line really didn't look parallel. Can you take a look at mine and maybe give me a pointer and explain what I did wrong? Anyone need some individual help? All right, then we come to construction 11. And this is perhaps where we have the most struggle. And this was taking any length line, and we'll go with that long, and dividing it into any number of equal segments. I wanted 4 equal segments. Ethan, what did I say we should do first?
Draw a line from that point, a long line.
Good, and I recommend coming off at some angle. We could go straight down, but you're going to have a hard time with that. So I recommend maybe coming off at some angle and make it nice and long as you can get it. The reason for this is the longer the line is, the bigger you can mark off those segments in the next step, right? And the bigger the segments, the easier it's going to be to construct. When your compass is open a tiny amount, it's really hard to maneuver the compass. You want more space. So a nice long line is going to help you out here. And then I just alluded to it, Ethan, the next thing we'll have to do is...
Copying. Wait, what?
help in Genesis.
An arc and
you can.
Not yet.
You don't do that?
Not yet. Okay, maybe that was the problem. No, it wasn't the problem, because I don't know what you did. Kendall?
Can you mark off segments?
You mark off segments, and since I wanted 4, you mark off 4 segments. They can be any size. They can be this size. They can be this size. They can be any size that fits on the line, or that would fit on the line if you extended it, right? Now, I don't have a whole lot more room to extend. On your paper, since your paper goes down, you might have had more room. But I want to try to find an amount that I feel like I could do 4 of. I don't know. I think I can get 4 of those.
You don't have to draw it below the line, the arc, do you? Or the line, you don't have to draw it below the original baseline?
I'm sorry, so you're saying you could draw a line coming up?
Yeah.
Yeah, absolutely, you could.
That's what I tried.
Generally speaking, there's more room to draw, because normally we're like, okay, let's draw this line, and there's going to be more room below than above, but no, I've shown it both ways in the past. So you mark off any 4 segments. Now, I recommended we do a couple things before we try to go to the next step. Ethan, do you remember what those 2 things are? Not yet, that's the next step. Before we do that next step.
Oh, marking off the end of the line.
Yeah, let's scribble off the excess here, just so we're not tempted to use it for our next step. Because the next step, the number 1 mistake I've seen is students coming down to this end point here, and that's just wherever you happen to choose to stop. So it's not a special point at all. Let's scribble it off so we're not tempted to use it. I also recommended we... There we go, number. These points at intersection 1, 2, 3, and 4, because there's about to be a whole lot of arcs all over this paper, aren't there? And so numbering these will help us to remember which points are the actual important points. You could also make little dots if you wanted to. The bigger you make your dot, the less precise you're going to be. So I recommend not doing that, but simply numbering them. All right, then, Genesis, we'll do what Ethan started to suggest a moment ago.
draw a line to that little point 4,
Good, from point 4 back up to
the original line.
the open end point of that line, right? So go into this end. We've already got one end point used up. Let's use up the other one now. And draw that line. Now, once we've got that line drawn, we now need to construct, Kendall, a series of... We're going to use some angles, but it's because we want to get some, class, parallels. We want a bunch of parallels that cut off 1, 2, 3, 4 equal segments on one transversal, so that the same parallel lines will cut off equal segments on the original line, which is your other transversal. So we want a bunch of parallels. And to get parallel lines, class, we need equal angles. Well, we only have 1 angle so far, right? Here's our parallel. Well, it's not parallel to anything, but it's going to be parallel, right? And it makes this angle here. So we want to make this angle here copied at 3, 2, and 1. So again, we're going to do a lot of construction 3 here. A lot of copying the angle, where you're going to take your compass and maybe check and make sure you did this correctly. Make sure you open it just inside the 3 point. Okay? You don't want to overlap the 3 because that can make your life confusing. I want to make an arc that goes all the way across the angle. Then we want to go to the 3 point because we were at the 4 point before. Go to the 3 point now. And remember, Genesis, starting here and going out. But make sure we cross this line. And then cross this line and go out. Cross this line and then go out. Because now that's 1 angle, but we need to get that exact measurement, right? So then we're going to measure that angle. And make sure you make that little mark right there, so that way you can see that it's just exactly right. Because if it's a little bit off, all your lines are going to be off. Okay, we want it to be perfect. And we're going to measure from this line on this arc. So we're not measuring from the 2 point. we're measuring from this arc. Just as we were measuring this arc here, we're going to measure this arc here, and then measure this arc just inside the 1 point, and then this arc just inside the beginning of the line. And we're going to connect those little tick marks, if you will, back down to the 1, the 2, and the 3. So from here down to the 1, and then from here down to the 2, but remember it has to intersect the line, right? So make sure we actually take it all the way through here, and then from the 3 and through here, of course, making sure it goes through the line as well. And we should have 4 parallel lines that cut off, as we already know. We know there's 4 equal segments here, and we've proven then that there must be 4 equal segments here as well. The way you know you did it right is if it looks like we've got parallel lines. Okay, if it kind of looks like that, strong internet signal that used to be, right? Nowadays it's the little archy thing, but it used to, y'all remember when in the bottom corner it used to be just the step. In fact, on phones I think it still is, isn't it? On the top of your phone you see how many.
Not anymore.
Not anymore. My phone's old, so.
Yeah.
It is okay. My phone's still old, but it's apparently not so outdated.
All
right, anyway. Questions on this? It also looked like xylophone. Anybody know what a xylophone is? Anyone played a little kitty xylophone before? It's really loud and obnoxious and high pitched. It's the little panels that are like longer and shorter. And the little short ones make little high pitched noises.
Like a rainbow.
The long ones make loud noises, usually colored like a rainbow or something. They got some at the park down by the Riverwalk. Anyone seen that park? Anyone played on the little xylophone thing at the park? Okay, I will confess I have. I have small children though, so I can justify it. But anyway.
I can't justify it. I was like 14 when I did it.
You're just like, there's all these little kids around, but get out of my way, kid. I want to play the xylophone in a minute. Anyway, questions on this? Let's practice this one again for sure. Does anyone need to practice 9 or 10 again? Anyone feel like you need 9 or 10 again? All right, let's at least practice construction 11 one more time then. And so maybe if there's room on your paper, or get out another sheet of paper. Again, doesn't have to go in the notebook, but let's go and practice one more time construction 11 before we get into our next couple of constructions, which we'll learn today.
Do the constructions we learned today build off the constructions we learned yesterday?
Not entirely. Friday, whatever. Last lesson. Hey, somebody watching on YouTube might watch back-to-back days. I'm just saying. Like, it depends on how the school year falls. All right, so go ahead and draw a line. And let's see. Kendall, you had the highest grade on the last test. I want you to pick a number between pick a number between 2 and 7. 5. All right, we're going to divide this line into 5 equal segments. So, we're going to divide this line into 5 equal segments. So, what do we do first here, Chris?
Draw a big long line.
Big line, where do I draw it? Just anywhere?
Yeah, just draw it. On one of the endpoints.
Good, coming off one of the endpoints. Again, technically you could go up or down. I don't have room to go up, so I'm going to go down, but you could go up. It's not wrong. Yeah. All right, in fact, I think the textbooks might show the line coming up. I don't really look at the book very often, but I think it might have a line going up.
Mr. Nebraski hates textbooks.
No, I like the textbook. I have nothing against it. I just don't look at it very often. I will say the guy who wrote the textbook, Mr. Eric Collins, who was my teacher, he always had a spiral notebook, and that's all he used. Like, he almost never used his book. So I'm actually stealing his teaching style, and by stealing his teaching style, I am neglecting the book he helped write. So, anyway, so it's true. All right, so anyway, so we draw a big long line coming off at an angle. Then what should we do, Jamie?
We measure somewhat equal, or try to get equal parts on the line.
We better not just try to get equal parts. We better get equal parts. How many equal parts?
5.
5, because that's the number Kendall gave us, is 5. And now again, I wouldn't go too small, or it's going to be really hard to make those angles later. Okay, that last step of making those angles is going to be really hard if you go too small. So bigger is better as long as you can fit them. It's going to be close, but I'm going to give it a try. Okay, so 1, 2, 3, I'm not going to make it. 4, I'm going to go just over 5. Now, what do you do if, like me, you accidentally go just a nudge over? You can extend the line. You be careful to extend it exactly. You know, sometimes you try to extend the line and the new line kind of is a little higher than the old line. Make sure you're very careful to extend it just as perfectly as you can. I'm actually going to retrace some of the old line first to make sure that it just extends just right. And now if you're smart, which I wasn't just now, you're going to extend the line right to that point, not through that point. But if you are stupid like me just now, and you go through the point, what should you do, Quentin? Yeah, scribble off the extra here. Now, the whole reason I did it was purposely so I could remind you to scribble off the extra. It wasn't entirely stupidity, at least that's my story and I'm sticking to it. But Audrey, now what do we do? Good, and we hadn't numbered them yet, but I'm going to call these points 1, 2, 3, 4, and 5. We do connect that 5 point to the free end of the given line, that first line which we are attempting to divide into 5 equal segments. Once we have drawn this line, then what, Genesis?
Do we have to measure an arc at 5?
Well, we don't have an arc at 5 yet, so we need to put an arc, right? So let's go down to the 5 point, and let's make an arc across the angle at the bottom. So by drawing that line, we get an angle down at the very bottom, kind of like where the extra syrup sits in a snow cone. We're going to go down to where the extra syrup is in the snow cone and make an arc. Okay, how many like snow cones? How many think they're stupid? Okay, I cannot stand up. All the syrup runs to the bottom. You're like just squishing the ice out of there and like get rid of the ice. Let me get down to the syrup at the bottom. It never stays where it's supposed to, but maybe I've just had bad snow cones. Maybe that's the problem. Maybe the people making them just didn't know what they were doing. And anyway, I'm not going to vent on snow cones here, since so many of you like them. All right, so we're going to go to the 5 point. We make that arc, but don't close the compass once you've made that arc, because once I've made that arc, Genesis.
You're going to make a same arc on all the segments?
Good, go to the 4 point. We were just at the 5 point. Go to the 4 point, make an arc. Then the 3 point, arc. 2 point, arc. Actually, there's just a 3 point arc. There's not a 2 point arc. Anything inside the 3 point arc is 2 points. But anyway, and then the 1 point arc.
I can't make those.
We know. All right.
I'm not the only one.
Hey, more practice, my man. That's what it takes.
I'm 420 today.
All right. So we've made a bunch of arcs. We got arcs everywhere. Here an arc, there an arc, everyone arc, arc. All right. Mr. Dasky had a construction. 1, 2, 3, 4, 5. All right. Now what, Ethan?
You
Genesis give us a whole bunch of arcs.
measure the arc
At
the arc, like
the bottom arc, right? The bottom of the snow cone.
exactly.
Measure it.
There you go.
All right. Once I got it,
You do the rest.
mark off that same measurement at all 4 other arcs. And if you were precise and accurate about it, then when you connect the dots, all 5 of your lines, class, should be
Parallel.
parallel.
Same thing.
Not same thing. Parallel and equal do not mean the same thing.
Mine good.
Once you're done, hold your construction up so that I can see it. I want to see how we did. Again, the way I can tell if it's accurate or not is usually just by looking at the lines. Do they all run parallel? If so, you probably did it right. If not, somewhere along the lines, we did something wrong. But all the lines should look parallel. All right, so what we want to do is we want to measure this arc, the arc at the bottom of the snow cone, correct? And mark it off there, and there, and there.
So my
And
I
there.
must have closed my
The compass close a little bit, but then the other thing is, we've already got a line to the 5 point. This point here goes to the 4 point. And it should run roughly parallel. Then the next goes to the 3 point.
So I did something very idiotic.
2.1 point. Yeah, somewhere along the line things fell apart on us. We're going to practice it again tonight. Okay, now, it's got to go to the 4 point. So here's the 4, right? You've got to connect the 4 to here, and the fun part is, so you might want an actual ruler, especially if you're going to make a line this long, okay? You got this is what, about a 4-inch protractor, so a bigger protractor, or even bringing a ruler with you to class would be good. So, yeah, and then up and so forth. So yeah, make sure you connect all the way to the 2 point, the 1 point, and so forth. A little bit smaller arcs here would have helped. Now again, you don't want too small, but if it's this big and the line has to be this big, yeah. Good. Looks good. Alright, so we're measuring across here. Oh, okay. So you actually went all the way. Oh, this here is the 4 point. Okay, so you measured here. We want to measure it here on this. So this was your next arc. This would have gone right about there for sake of illustration. And there. And there. And you never did make the arc. Here, so don't forget, you would start at the 5 point, then the 4, then the 3, then the 2, then don't forget to go to the 1 and make that arc. And of course, we've got the measurement here. We also, of course, will mark that off there. The final step, you're going to join this 4 point to the intersection, 3 point to intersection, 2 point to intersection, and then the 1 to the intersection. That'll finish it out. Good. And where's yours go? You started to, and then you caught yourself. Good. Now there's 2 tick marks for each of these. I'm a little confused why there's 2 of these.
Oh, that's what the arcs are.
Oh, you started at the top.
Yeah.
You did.
Still parallel.
Does that technically? I guess technically start at the bottom of the snow cone. Let me think on that. It may be sound, and it looks like it would. I mean, as long as it makes parallels, it would have to be.
Oh, I know what you mean. You started down here.
Right, you start down here.
Yeah, I started there.
Yeah, start at the bottom.
Ethan, stop being different.
Let's practice one more time. Let's practice one more time, and let's do just 3 segments this time.
Did anyone do it perfectly?
Yeah, we had a few. Maybe a few. The people I didn't spend a lot of time with.
So
It's not because I hate them, it's because they didn't need it. Alright, draw a line, let's divide it into 3 equal segments. So, follow along with me, and Quentin.
You said 3?
I assume you have a long enough ruler edge yourself? You don't have a ruler. As long as you can use it effectively and get the straight line.
I don't have
All
a
right,
ruler
so.
because I don't let anyone control me.
Not even God, huh?
Oh, he's not a man.
You said anyone. God is a being.
Any man.
Oh, you don't. Okay, that's not what you said, though. All right.
Get it straight, Chris.
Be quiet, Quinn.
All right, so drawing a long line. Following along with me. One more time before we get ready to move on. Arc. Arc. Arc.
You did 3?
No, we were doing 3 of them. You may want to go ahead and just, not real big, but it'll make it a little bit darker and it'll catch your attention. Maybe for some of you, if you've been struggling, go ahead and number and dot the 1, 2, and 3 points before you do anything else. Go ahead and number and dot the 1, 2, and 3 points. And I'm scribbling excess. Now remember, we're going to connect that 3 to the top. All right, here we go, Ethan. You're going to have to close the compass just a little, and while you're down at the bottom of the snow cone, over at the bottom of the snow cone, all the way across the snow cone. In order to do that, your compass point is on the 3. Put it on the 2. Make that same arc. Then put it on the 1. Don't forget the 1. Make that arc. So you're at the 3, arc through. At the 2, nice big arc. At the 1, nice big arc. Now you're not putting the point at the 2. You're going to measure the arc. You're not measuring from the 2. You're measuring the arc itself. So measure the arc itself. And once you've measured the arc, not from the 2, but the actual arc, go to the next arc. Not at the 1, but just inside of the actual arc. Then at the top arc. And mark them off. Then finally, go to this top arc, connect it to the 1. Then go to the next arc, connect it to the 2, but make sure you go up high enough to hit the line. And then the 3rd is already drawn for you. It looks kind of like the Adidas symbol now.
Yeah. Felt better.
Yeah. Yeah. There we go. Very neat. Good. Good.
I'm always neat.
Good.
Just see my locker.
I see your locker.
I have a very clean locker.
Just adjust it, try to get off as you can see. Alright, so we made the arc measure across to right here. To this arc, measure across. And go to this arc. And measure across. Looks like right about here to there would have been. And then there's something. These arcs were just a little short, like the paper pushed up. So again, when you hold it, hold the bottom of the point here, and turn it in your thumb. That may give you a more precise point. We're going to practice this again for homework. For now, go ahead and take out a new paper to go in the construction section, that reinforced edge paper preferably. And at the top of the paper, construction 12, C-12. Construction number 12 is one I've been looking forward to for a while, and if we'd had a little bit more time in the second quarter, we would have actually done this already once just for the fun of it, and that is circumscribing, or we'll just go circumscribe because I'm too lazy to write ing. Circumscribe a circle about a given triangle. Circumscribe a circle about a given triangle. Circumscribe a circle about a given triangle. Down below, if you would, not too big, but not too small, maybe sides from 1.5 to 3 inches or so. Try to draw an acute scalene triangle. So we're not trying to make any sides look equal, but we also want to make sure we have preferably acute angles everywhere. So a triangle that maybe looks something like this. We'd like to have all acute angles, especially that top angle. Try to get acute angles everywhere for sake of ease. I'm going to show how you handle it if you had an obtuse angle or a right angle later, but for now, for sake of ease, go and start yourself off with an acute scalene triangle. Circumscribe a circle about a given triangle. Now, circumscribing a circle, you might recall, would require a circumcenter. Remember, going back to those concurrent lines. And the circumcenter, you'll recall, is where the three
intersections, the three
perpendicular bisectors would meet. So you realize if I could have 3 perpendicular bisectors, I would know the circumcenter, and then I could draw a circle around it, right? So we kind of, by proving that the 3 perpendicular bisectors must meet at a point that is equidistant from all 3 vertices, we've kind of already proven this construction. Step number 1, come up just a few, 4 or 5 lines from the bottom. Step number 1 is to construct the perpendicular bisectors of 2, put a little asterisk, sides. Construct the perpendicular bisectors of 2, put an asterisk, sides.
What's an asterisk?
Sorry, what I'm thinking.
An asterisk is that. Now, an asterisk is used to denote there may be a little exception here. Now, for instance, you've heard of, for instance, Barry Bonds. If he gets elected in the Hall of Fame, they should put an asterisk next to his name, people would argue, because he was on steroids pretty much his whole career that he did anything.
Hey, it wasn't illegal then.
And it wasn't illegal then, it's true, but what he was able to accomplish was artificially induced, right? So they're like, okay, yeah, he got 73 home runs, but...
73 a lot.
It's the most ever.
In
a single
career?
season.
Oh, in a season.
Single season, 72. But anyway, so an asterisk, and the asterisk idea is this. Technically, if you drew just 2 perpendicular bisectors, they would intersect at the circumcenter, wouldn't they?
Yep.
Why would you ever want to draw 3 if you're lazy? Well, if you're lazy, you wouldn't. But on a quiz or test, you might draw a 3rd one just to make sure you really got the circumcenter right. So normally, I would say just do 2. But if you wanted to on a quiz or test, a 3rd one wouldn't be a bad idea. So number 1, construct the perpendicular bisectors of 2, put an asterisk, because you might want a 3rd one, sides. And in parentheses, put C-1, because you're just going to do construction 1 twice. Let's go ahead and do this first step together. Remember, you'll pick one side of the triangle. Let's just go with the base for sake of ease. Open the compass up more than half. Make an arc above, arc below. Go to the other end of the base, arc above, arc below, and then connect the dots. Remember, we said 2 sides at least, right? Here's what I'm going to recommend to you. I cannot do this because my chalkboard is stuck to the wall. I would rotate the paper so that one of these becomes the base. So you can just do the same thing again. To me, that seems the easiest thing to do. I can't do that, though. I would also recommend changing how much your compass is open for one of the other sides. This way, your arcs don't happen to coincide on top of each other. So I'm going to go with this line here. You may wish to rotate your paper. I just can't. I can kind of rotate my head, though. So we've got an arc above and below. Go to the other end. Arc above and below. And we'll connect the dots. Again, you may wish to go ahead and do a 3rd one just to make sure that all 3 perpendicular bisectors meet at the same point. Or you can stop with 2. And there, where they intersect, is your circumcenter. Step number 2. Step number 2. Once you've constructed 2 perpendicular bisectors, one of one side, one of another side. Again, this is easier done not in your binder, but putting it in the binder later. Step number 2 is to measure the distance from the circumcenter to any vertex. Measure the distance from the circumcenter to any vertex. Now technically,
Say that again.
measure the distance from the circumcenter to any vertex. Technically, the distances should all be the same if you did it correctly. We proved that it had to be. So step number 3, once you've gotten that distance measured, draw a circle. Step number 3, draw a circle. Once you've measured that distance, draw the circle. Hold on. Okay, I didn't actually see the mark there. Okay, I gotcha. Again, when you draw it, strategy tip, just hold the point. Super easy. Just hold the point of the compass, not the top, because that's when things tend to stick. Just hold down here and spin around, and you got it. Oh, oops. One new sheet of paper for the notebook. You're going to copy it later. Okay, that's fine. That's fine. More work, but it's good practice. So it's like you kind of added a steeple to your triangle to make it hit. Am I right? All right. So when we measure, we want to measure from here to any vertex. So you measure vertex being here. So it actually hits those instead of going outside.
Yeah, that was kind of a cluster on my page. I couldn't tell what.
Somehow you keep leaving big old holes in the paper. So maybe a teensy less pressure and a teensy less wiggle and more just precise turning so that it doesn't actually tear the paper. All right, so the circumcenter is going to be wherever the perpendicular bisectors meet. By definition, that's what's in your notebook. So you're going to measure from there to a vertex, and it should be the same no matter which vertex you pick. All right, let's practice it again. So once you got that down, go ahead and turn the paper over. And on the back side of the same sheet of paper, let's practice again. This time I want you to try to make a right angle first. We're going to try to do a right triangle this time. So approximately, it doesn't have to be perfect, but try to get yourself what appears to be a right angle, and then connect the ends to get a right triangle. Try to get yourself a right triangle. Let's see what happens here.
Something bad going to happen?
Well, you have to wait and see. You'll find out. All right. Once again, the first thing we need to do, class, is to construct 2 at least perpendicular bisectors. So open the compass more than half, arc, arc. Other end, arc, arc. Connect those dots. There we go. Then pick another side. Open the compass more than half. So you're going to want to change the compass, remember. In my case, since I'm doing the vertical line, I'm going to go side to side on this one. The fun part is when you got arcs that are really close together, keeping track of which arcs are which. All right, so it's these 2 arcs, and of course these 2 out here. And a good way to check this is make sure that your line, when you draw it, looks like a perpendicular bisector. If it's coming at a weird angle, now you got a little problem here.
Okay, I have the same problem.
My lines don't intersect. What do you suppose I should do?
Connect.
Extend it. Yeah, extend the vertical one in my case to make sure that it does hit.
Are they not supposed to intersect?
They are. See, they just intersect.
Because mine intersected right off.
Well, they could. Mine just happened not to because they weren't quite long enough. So it just depends on how much your compass is open, frankly. Wherever they intersect, and notice this time my circumcenter is just outside the triangle. Well, once you've got that point, it should still be the same distance from each of your 3 vertices. So you can still circumscribe a circle. Very nice. Hold down lower. It's catching on the paper. Just hold down here. You know where my fingers are? Hold it down there. And then pull on the paper. It doesn't catch as bad because all the pressure is just on the point instead of on the other. Good, better. Good. Good. And good. Now, think about it. This point for some of you was just outside the triangle. How many were just outside? Anyone just inside? Anyone on the triangle? If you truly had a perfect right angle, it should have been perfectly on the midpoint of the hypotenuse. Why? Because if the center is on this, then this is a diameter, which makes this a semicircle, and any angle inscribed in a semicircle is a right angle. So if you really had a right angle, it should be the midpoint of the hypotenuse. My angle was slightly obtuse, so I have a slightly minor segment.
So that means
So let's, in the couple minutes we have left, go ahead and make an obtuse angle. Don't make it very big. Go about like 1 inch and maybe like 1.5 inches. Maybe 1 inch and like 1.5 inches or so. Don't make the lines too long, or you're gonna have a really hard time completing this. And then connect the ends of the obtuse angle to form an obtuse triangle. Because now, with an obtuse triangle, the circumcenter is going to have to lie outside the triangle somewhere. Once again, arc, 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 arc. Connect those dots. By the way, strategy tip, some students struggle because of all the little arc markings. If you want to, you've got your eraser. After you've made these markings, if you wanted to go through and erase some of the extra so that you don't throw yourself off, that's not a bad strategy. It takes a little extra time, so you may not want to, but it's not a bad strategy if you're trying to keep from getting yourself confused. And once again, you'll notice that my 2 perpendicular bisectors won't actually intersect when I first draw them. I'm going to have to extend, in this case, both of them to get them to meet up. And so if you have an obtuse angle, your circumcenter should lie outside the triangle. And that's okay, because that point will still be equidistant from all 3 vertices. If it was drawn right, mine's slightly off apparently. The fun part is if you made your triangle really big, which I tried to admonish you not to, and mine I just put too high on the top of the chalkboard, you run out of room to make the circle. But there we go. Questions on construction 12? All right. Your homework is to complete handout 5 for homework this evening. Complete handout 5 for homework this evening. You will have a construction quiz tomorrow over constructions 9 through 12. construction quiz tomorrow over constructions 9 through 12. I'm going to pick 3 of them to be on the quiz. So 3 of the 4 constructions will appear on the quiz. You'll find out tomorrow which one won't be on the quiz. But, construction quiz tomorrow. Complete the handout. We'll take a look at it before the quiz by way of review. You are dismissed.